Hit the record button. Great. Okay. Well, good morning, everyone, or good afternoon from here in Abu Dhabi, where I arrived about 4.5 hours ago. So if I'm a little jaded, please forgive me. I've been on the night flight. So my name is Darren Jones. I'm the ESG director for a company called Sonihull, who are the world's largest producer of ultrasonic anti-fouling systems. In fact, we've been around over 15 years. Got over, I think it's now over 6,000 vessel years of operation under our belt, and operate at sites around the world, including this one I'm in. So we're actually a British company based out of that well-known maritime centre of Coventry. But I'm in Abu Dhabi because this is where our R&D centre is, as well as an ops centre for dealing with lots and lots of global commercial shipping. R&D centre here, of course, because if you're going to be working on testing marine growth, being somewhere where you can do 12 tests a year, I think once a month, is rather handy, because it would take us 12 times longer to do it in the UK with our UK weather. So I think I can share my screen. Let me see if this works. This will be good if this all works. I'll be very pleased. Yeah, and I'll stick that on to now with a second. Slide from beginning and let's go big. Right, hopefully you can all see my screens. So yeah, Sonihull, biggest in the world at what we do, and been around for 15 years. As ESG director, I deal not just on the environmental side, but deal a lot with government at all different levels, and I'll come to that in a second. So one of the key things I've done in the last couple of years was I was also the inaugural chair of the IMO's glow fouling GIA, which is doing similar to what happened with ballast water, only this time trying to involve the industry at the sharp end rather than imposing a load of regulations, which frankly are rather expensive and people find a challenge. So that's me, and that's Sonihull. So where are we? What's happening with biofouling, and why does it matter to you, and why does it matter to the vessel owners? And whilst some of the slides you'll see focus on commercial shipping, clearly not just Sonihull's ultrasonics, but other ultrasonics, and this entire biofouling issue is an issue regardless of the size of your vessel, and also regardless of the material it's made in, pretty much. So why is biofouling moving up that regulatory agenda, and what does that look like? Well, it's moving up the regulatory agenda both at a local level, and by that I don't just mean national level, I mean local. You've got different ports around the world bringing different interpretations, different states in the US bringing different interpretations into what they're finding acceptable around biofouling. And like I say, there's a real focus, particularly in the Mediterranean now, on and what they're doing in terms of that top driver invasive species. That's also a huge thing in the Great Lakes in the US, and they're extremely hot on it. So the drivers really are invasive species. As some of you may have, if you weren't sleeping off your Christmas turkeys back in December, have seen the Australians decided to, as they'd promised to, stopped and refused entry to a cruise ship, and had 3,500 very unhappy people that were on their lifetime cruise to Australia and couldn't enter the port because there were invasive species in some of the niche areas. And the Australians had flagged they were going to do this, the New Zealanders had flagged they were going to do this, and the industry put its finger in its ears and decided that they would never do that. But they did, because they take their biosecurity extremely seriously. The other driver that's now really coming into this is greenhouse gas emissions. So the IMO issued a report. I actually launched it in 2026 at COP26 2 years ago. The preliminary report, the final report came out in November this year, and it's basically showing the actual effect of biofouling, which has surprised the industry, particularly in commercial shipping. If you walked into a room of 50 superintendents for commercial shipping and said, what's the effect of all that drag on your emissions, and also having not very cool cooling systems because they've got growth in, and you'd have had 50 different answers from 3% maybe up to 20%. Well, the full and the most thorough examination ever done, involving multiple geniuses and professors from around the world that did all the modeling, showed that a container ship with 1% calcareous growth on its hull and propeller area would produce 55% more greenhouse gas emissions at its cruising speed. So the industry has suddenly sat up and gone, right, okay, this is something we need to take seriously. And not only has the industry done that, but so have regulators, as they've realized that this is now something to do with climate, not just to do with invasive species. The other piece that has absolutely come to prominence is regular cleaning or over cleaning of some of the ablative coatings. Some of them contain microplastics. That's obviously a hot topic. And then on top of that, you have new biocide regulations being looked at in Europe, in the US, and at local levels. The new chemical regs came in January for the EU, which, while doesn't specifically deal with coatings, what it does do, it deals with chemicals across the piece, and it limits the ingredients that the geniuses in coatings can put in. And then you've got some nations, namely Germany, Sweden, and New Zealand in particular, are going all out against copper. To the extent I was at the IMO in November, and we had one nation calling for an instant ban. The consequences of that would be utterly ridiculous in terms of invasive species and greenhouse gas emissions, and would be far worse than the amount of copper that's going in. So that was kind of dealt with, but they are the major drivers. The IMO is looking at this. There's some cracking resources on the Biofouling website, not just for recreational vessels, but for all sorts of vessels. I've just put a picture up there of the management for recreational boating that they recommend. There's also a series of posters you can download and you can give to marinas and ports or whoever you may be working with, which tries to highlight how biofouling can be managed. And actually, one of the things we always push is that if you manage your biofouling, depending how much you're using your vessel, you are likely to get a saving. If it's a powered vessel, you're going to get that on fuel, and on other vessels, you're going to protect your coating and keep it going for longer. And again, if you're a powered vessel and you're looking at your niche areas, your cooling systems, you're liable to have far fewer maintenance problems. So I'm going to teach you all how to suck eggs, I know, but I am just going to explain what biofouling is and how it's formed, and how it's formed is key. Within 10 minutes of a surface being in water, it will get bacterial cells settle on it, onto that hard surface. They will then propagate, and that's your biofilm. That slimy, thin biofilm is the food source for pretty much everything else. They all like to feed on it. So it creates a complete ecosystem that's very friendly to lots and lots of things to grow on a vessel. And the other thing, by the way, we get quite a lot with recreational vessels, you don't hear so much with commercial vessels, is particularly on super yachts, they really don't like slime or any mess on a boat. They want it to look absolutely pristine, which is quite good because that drives some good behaviors. So the basics of biofouling have never changed, never will change. It's always going to be there. And how we deal with it today is what I'll go on to next. So the technological mix that we use, and you'll all be aware of, there are coatings. The coatings world is changing. There are a whole host of different sorts of coatings with different properties. and different ingredients. And we're seeing, again, local regulation around that. What biocides can they have in? How much copper then can they have in? In California, I'm not sure if they've passed it yet, but there were certainly moves to prevent recreational boaters painting their own vessel. And that was under effectively their cost regulations, their chemical handling regulations, rather than any maritime issue. So the coatings are there. The coatings are changing. There are all sorts of things coming in now, for instance, graphene on some of the harder coatings, some of the ablative coatings. You've then got things like silicon coatings, which are extremely soft. What we found, and everybody's found, is coatings costs don't tend to go down, and their lifespan doesn't tend to go up very much as the coatings companies battle with the regulators. And in fact, yeah, fair play to them, they do a great job of it, and they are trying their damnedest to come up with something that is green, doesn't damage our oceans, and protects our vessels. So they do a great job, but the landscape's changing. There are new challenger brands coming in with different thinking and new things. That's there. The one thing's for sure, every vessel is always going to need coating. Regardless, you're going to be wanting to coat it for, say, every vessel. Some aluminium don't need it, but pretty much every vessel is going to need some form of coating. So coatings is in the mix, that technological mix, and how we're dealing with it. Cleaning and grooming. Clearly, on the smaller craft we're talking about today, regular cleaning is possible for many. Depends if they can haul out cheaply or not. We quite often see people jumping over the side with a brush. Key with that, and the difference between cleaning and grooming, I'll touch on as well. Cleaning is very much, you've got fouling and you are cleaning it off. And if you've got barnacles and you are using a brush, you're likely to be using a very hard brush. You're going to be damaging your coating. And as the barnacles come off, you're potentially damaging the coating as well. If you're grooming, which is literally only cleaning so regularly that you're just getting the slime off that food source, you're likely to be able to use softer things, sponges, whatever, and protect your coating. So we see that, and I'm already starting to see and hear within the commercial sector, there are robotics for cleaning, and I know there are companies already working on smaller drones to do in-water cleaning. Now, the issue there that you're going to get, if anybody asks you that, is it's going to be entirely down to the rules of the marina or port they're in. Still to this day, the majority of ports don't allow in-water cleaning. So when people do jump over the side, they're probably breaking the rules. If they start using drones and whatever, they do need to check with the marina operator to make sure they're not falling foul. And also, if they have got, if anybody is doing in-water cleaning of any kind, would it be people, if they have got invasive species, or even suspect they may have, they do need to make sure they are capturing everything pretty much, because otherwise the actual act of cleaning increases the spread of the invasive species. The other piece in the technological mix has traditionally on cooling systems, and you do see this on quite a few super yachts. On the smaller craft, not so much, but ICAF systems, impressed current, where an impressed current is passed through to get sacrificial anodes to send one lot of copper to the other one side of a box cooler or a sea chest. Increasingly, we're seeing copper resistance in certain ports and marinas. And again, this is something the regulators really have their eyes on. They are determined to work out how to remove copper. And frankly, I could see this going on the journey way before they get copper out of coatings, and that would be more sensible. Incidentally, the journey, as I'll get onto now with ultrasonics, the journey for regulation at the IMO is 32 years. That's the standard. Now, there is a whole conversation as greenhouse gases are now in the mix that 32 years is too long to wait. Whether or not they can pull what would happen with COVID vaccines and go, do you know what, actually what used to take us a decade is going to take us a matter of months. We'll need a collective of will across multiple nations. So I'm not holding my breath, but that regulatory vehicle has started to move, albeit extremely slowly. So ultrasonics. Ultrasonics are now in the mix again because they are a green technology. They use no chemicals, no biocides, nothing nasty, and they're actually a preventative. So ultrasonics is not there to clean a dirty vessel. Lots of people think it is, and they misunderstand it because they are used to seeing. Well, their normal understanding of ultrasonics is the ultrasonic baths that you'll see in a motor garage where they clean carburetors and dirty bits, or potentially in a jeweler's where jewelry will be cleaned. Ultrasonics for biofouling is a different animal. It is different frequencies, different decibels. It is there as a preventative, and it is to prevent those single cells sticking. I'll get to the science of that shortly. Ultrasonics has been around for decades. It was first noticed that on US naval vessels, that where the sonar was, they didn't get growth. So, and we're talking 50 odd years ago. In Sonihull's case, we're the oldest in the market with our equipment, and we started with this kit over 15 years ago now, here in the Middle East, where the growth was the worst, and the ICAF systems don't work anymore, and the coatings were struggling. So it's been around a long time. Yes, we're the largest in the market, but like I say, we have over 5,000 vessel years experience, and we're on some of the world's largest fleets. We're also on hundreds, if not thousands, of recreational vessels. Ultrasonics works not just on your hulls and not just on your cooling systems. It also can be put into propellers on the majority of vessels, as well as protecting thrusters, indeed, and also water jets. So if anybody's got jets, so Kongsberg jets will specify and fit Sonihull at factory if people want it. It's the only thing that can keep the jets clean, particularly in areas like Japan and Vietnam, where they have some real issues. So ultrasonics it covers a broad part of your vessels. So also in the technological mix, I have on there what I cheekily call sci-fi. There's the unknown, we don't know. There's one coatings company I know is trying to develop an ultraviolet tile, effectively, that will go on vessels. To be honest, I mean, it's great work they're doing. It's fascinating how they scale that up to be commercially viable, not just in terms of cost, but in terms of the ability to fit it things, and the ability for it to stay on operating vessels for a long period is beyond me. They are geniuses, who knows? But at the minute, I class that as sci-fi. So it's not out there commercially. People are talking about it. When it will come, who knows? But that technological mix, if you take the top four, and in particular you take coating, cleaning, and ultrasonics, there is actually no reason to have a dirty vessel anymore. None whatsoever. It is financially as well as operationally viable to have a clean vessel. So just a little more on the ultrasonics. There's just one of our systems, or a couple of our systems. There's a Duo, there's an 8. And the numbers all refer to the number of transducers. So an ultrasonic system, all it will be doing is using the ultrasonics. No chemicals or anything else. I'm just going to show you. That is the size of a transducer. About the size of a coffee cup. Now, on our system, can't speak for others, our system, one transducer on a steel hull, flat steel hull, or a GRP actually, will cover around a 5-meter radius. But that does depend on bulkheads, welds, joints, all these kind of things. So it is very much down to vessels being surveyed, understanding what needs protecting and what's in there. And interesting, speaking to a load of surveyors, the number of times we get drawings of vessels and then go to the vessel and it's nothing like the drawing, and there is stuff in the way and blocking it, and welds and joins and all sorts of wonderful things. And anything that stops the transmission of the sound wave is going to interfere. So these are modular systems, so they can be put around the vessel. Just to explain how the ultrasonics actually works. Now, to a load of surveyors, there's a terrifying word, look, cavitation. I can always tell when I'm talking to engineers in a big room, because all the engineers sit up the minute they see this slide. But believe me, it is what we call non-inertial cavitation. We've worked with the Centre for Industrial Ultrasonics at Warwick for many, many years to understand the process. And like I say, we here in Abu Dhabi have the world's only full-time anti-fouling ultrasonic laboratory, which is full-time staffed, fully kitted up. Now University of Warwick come and ask us things rather than the other way around. So the cavitation process is non-inertial, i.e. it is not strong enough to damage a surface. That is key. This is Sonihull's kit. I can't speak for everybody else. I'll come to that later. And it literally is a case of creates a small bubble. The small bubble collapses in on itself. And it really is very gentle, but that's gentle enough to prevent single cell organisms. And that's all you're about. And we are turning whatever surface we're on into the medium to have these bubbles go across. Now, Sonihull, our transducers almost always go on the dry side. So we'll be on the inside of a vessel, on the inside of the hull, making the outside of the hull effectively the speaker of a sound system, an ultrasound system. So those waves will pass through. When we, for instance, go on a propeller, we'll go on a bearing or we'll go on a P bracket, and the sound waves will travel through that, and then they like to escape through the propeller. They like to go to the sharp edges. So that's how we get through a propeller. And if you think on a bearing, it's got grease. The other time that people tend to really think of ultrasonics is when a pregnant lady has ultrascan on her belly, and what do they put on there? They put an oil, a grease, a gel. So using things like bearings is actually quite good and really helps, and really helps with this microscopic cleansing effect. So that's kind of the science. What we've tried to do, and we think ultrasonics really does, is meet that crossover where you've got a technology that's actually cost effective and works and is environmentally friendly, because we're seeing so many changes in the regulation, like say both very locally, sub-locally at marine level, right up to IMO level on a uber national basis. And people really want to future-proof their vessel. They don't want to put something on it or spend money that's then going to be told within 2 years, no, sorry, you can't have that on. And they also don't want to spend money on something that doesn't work. What they do want to do is reduce the cost of their boating. That's absolutely for sure. Here in the Middle East, slightly different. And to a certain extent in places like Florida, actually what they want to do by preventing biofouling is make their vessel go faster. Which it does. You wouldn't see Max Verstappen driving around with a load of barnacles on his car. He certainly wouldn't be on the front of the grid. So we're reducing the costs of fuel. We're improving the performance of the vessel. We are also reducing that maintenance cycle, be that on engine maintenance because you're over revving because you've got an inefficient propeller, or you've got cooling system issues if we're on a box cooler, crossover pipe, sea chest, all these kind of things. Incidentally, the equipment I showed you included was mainly our commercial side. The recreational is very similar. slightly different price point and slightly different components, but extremely similar and designed for the market, absolutely designed. Also in terms of its power draw, very, very low power draw, originally designed to go on sailing vessels and to sit there for a few weeks running off a battery. And sit there is an interesting thing, because unlike coatings, unlike any other preventative or any way of dealing with biofouling, the ultrasonics is always on, and it doesn't actually need the vessel to be moving. So we're preventing even when you've got a static vessel. If you've got a static vessel, what you'll tend to see is a little bit of a buildup of a brown film. That is actually dead single cell organisms building up into brown. And as soon as you move the vessel off, it will come away. So that's one of the reasons we're excellent for recreational vessels, because they tend to be sitting quite a lot and nothing else is working. We find quite a lot of the marina operators like us as well, because at the same time as we're protecting the vessels, they tend to have less cleaning bills for there. I can't leave the greenhouse gas piece. It's absolutely enormous. We are currently working with one of the major yacht companies to see how we can basically become a standard for them. They want it. It's with their legal counsel, because there's been all sorts of things when I think we heard earlier actually, whenever manufacturers get involved in biofouling, they seem to end up in court. So we're doing this properly, but the yacht manufacturers are now being told by their various governments, similar to a car manufacturer, you've got to reduce your greenhouse gas emissions. And this is a real way of doing it, an absolute real way of doing it. And you're talking major percentages, particularly for vessels going fast, because the drag coefficient goes up exponentially with speed. We are talking the difference between a clean vessel and a medium fouled vessel is way into 50% of the fuel. That's what the modelling has now shown, and that, working with the British government in particular and the IMO, we're now able to demonstrate. So, and that's not an advert for ultrasonics, that is an advert for keeping a vessel clean. However you do it, it is worth keeping your vessel clean. So I'll just give you a demonstration of where we're at. You can see there's a box cooler. That's what it used to get like, 12 months. And once it's cleaned, because we go on a clean vessel, so you clean it, you put us on, and then you stay. This crossover pipe, that was on a Dutch barge. That number of mussels was actually what they were getting after 4 months. And here we're on a keel cooler, which we don't see a lot of. We see quite a lot of them in South America actually, and we've got a patent for the only bracketing that can get ultrasonics into keel coolers. But you can see the difference that it makes, and all this without using any poisons, biocides, or anything nasty. Just to show you another example, if I can get this machine to work now. Do I have to do that? Hooray, getting the screen. Come on, screen. Go to the next slide. You can do it. Great, it's my turn to have a tech problem. Hang on, I just need to move that. That's why I can't move that. Next. There we go. Done it. Right, there we go. Technology doesn't beat me. So here we have just an example. It's really funny talking small craft today, because some of the larger stuff we do really is impressive. So here we've managed to get the signal into a propeller, and we got it into the stern tube in the area around it too. And I think you can sort of see what an area that wasn't protected has growth. That propeller with no coating has remained clean, and that was just with a Sonihull 8 system. So that was just 8 transducers on a vessel of that size. And what that's meant for that particular vessel is, what they used to have to do is do regular rotations of the propeller while they're at anchorage, which is hugely inefficient. Really does burn ridiculous amount of fuel for doing very little. And even then, they were still having to have regular polishes. So that's what a Sonihull 8's done there. But for you as surveyors, what I really want to major on is what to look out for. I want to be absolutely clear, ultrasonics is unregulated. And despite my best efforts at the IMO and then being told that it's going to be 32 years, I desperately want it to be regulated for several reasons. One's a basic commercial reason that half the ship operators in the world don't do anything until they're told to, i.e. it's regulated. But that's obvious. But also there are environmental reasons, and there are reputational reasons for ultrasonics in general. So the biggest issue we have at Sonihull, despite all our years doing this, despite being on the entire fleet of the Dutch Navy for years, all these kind of things, the number of people that either tell us ultrasonics doesn't work or ultrasonics has caused damage. It is very much buyer beware. Anybody can knock up an ultrasonic device and claim it's an ultrasonic anti-fouling system and sell it. There are no rules, nothing. And a little bit like you could go and buy, if you think of ultrasonic systems as being a stereo, you think of the transducer as being a speaker, and you think then of the ultrasonic signal being a song. You can go and buy the most expensive Bose system with a great speaker, and you could play some Adele on it, and it would sound wonderful. It would sound like you were in the concert hall with an excellent singer. Or you could go to the local market and spend $2 on a cheap and nasty sound system, and then it plays a pub singer. They would both be called a music system, and the same goes in ultrasonics. It absolutely, if anybody's asking about it, you need to get them to do their homework, because not all systems are the same. And some of these people, some of the systems that are out there are literally being knocked up in a one-man band workshop. And not only are they not particularly effective at preventing biofouling, they are potentially dangerous or damaging. So the first thing I'm going to talk about that you need to look out for is your transducer materials. So this transducer, if the screen's going to behave, if I'm still, there you go. This is made of a Kevlar nylon, and the face of it, if it will just not fade out, is ceramic. Now, there's some big reasons for that. So that is a marinized transducer. That is not cheap to make, but it means it can be submerged. Even though we usually go on the dry side, we do go in some tanks. It is made of nylon Kevlar, because what we don't want, and I wouldn't recommend, is metal. We see lots of metal transducers, and there are a whole host of reasons, not least metal and high voltage electricity in a maritime environment, and then attaching it to more metal quite often seems to us completely bizarre and never seemed a good idea. So we've gone a route for that. The ceramic face, or the face of anything. So how a transducer is installed, I'll just go on, is for us, we affix, I shouldn't have done that, we affix a ring, and then the transducer is screwed into the ring. Or if we have a pipe, there's a pipe adapter, and you can see it has a radius that is specific to the pipe. Now you'll notice the pipe adapter is metal. Depending on the pipe will depend entirely what metal we use, because what you will get with dissimilar metals is galvanic action and galvanic corrosion. And we've seen this time and time again. We've been called in and we've seen it. So if somebody's having this equipment installed or they've already got it installed, you need to check that you've not got dissimilar metals in contact. You will see corrosion. We've seen holes burnt into steel because the mix of the ultrasonics and those differing metals is quite frankly catastrophic. So whilst our transducer's extremely expensive, let's be honest, to manufacture, compared to what we could do, we could get a similar signal, but it would not be something we would be happy with putting in a vessel. So that's what you need to look out for on that galvanic action. Signal type. So this is really important, particularly if you've got vessels operating in sensitive areas such as Canada, off Vancouver, or anywhere like Galapagos, whatever. So again, as it's unregulated, nobody regulates the signal. Noise pollution in the oceans is a big thing. Ultrasonics has the potential to be noise pollution. The song we sing is specifically in frequencies and at decibels that cannot and will not annoy or be to the detriment of whales, dolphins, etc., etc. Now, that's actually quite hard because the easiest way to prevent biofouling is to, frankly, play heavy metal and turn up the volume. Bang, 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 bang. It will keep it off. There are two reasons not to do that. One is potentially you could, over time, damage the surface. But secondly, that will create noise that will be detected by the authorities. And more importantly, noise that will be detrimental to the creatures of the sea, such as the whales and the dolphins. And there are systems out there that are banned, for instance, by the Canadian Coast Guard. Again, we get a bad rap for that because people just class it as ultrasonics. It's not. It's certain systems that take this different philosophy. Now, we're actually on Canadian Coast Guard vessels, so we're okay. So again, we've taken best part of 2 decades to come up with the right song that can both keep something clean and not annoy any creatures. So that signal type, just be really clear. Ask them, can they show you that they're not detrimental to whales and things. Install quality. Install quality is absolutely massive. Again, it would be a little bit like if you have a home cinema system fitted and you didn't fit the sound bar correctly, you wouldn't get the sound effects of a cinema. If a transducer is not fitted correctly and in the right place, it will not give out a high fidelity signal. It will not give out a crisp signal. The signal won't travel to where it's supposed to get. It won't come out correctly, and you'll basically end up getting growth. A transducer that is fitted poorly is just a waste of time. And actually, it's no different, is it, to coatings? If a coating is applied poorly, you will end up with growth, and your coating also won't last very long. So that installation quality, you need to be checking, has it been signed off by the OEM, or has somebody just bought this stuff off a shelf and stuck it in? Really, really, really important if you want quality. And again, this is where support network comes in. If a vessel's going to be doing any international stuff, if it is going to be traveling, you need to know that there's support around the world for it. We recommend on our commercial vessels, they get annual inspections from us, but we do recommend a very, very easy maintenance cycle for vessel operators in recreational, that they just check the transducers once a year and check they're getting crisp signal, which is very easy, but quite often not done. And again, if they buy off online, fit it themselves, and then find they've got a problem and there's not a local support, they've got a dead duck really, and there's not a lot they can do. So yeah, I cannot reiterate enough, please buyer beware. It is an unregulated Wild West. Ultrasonics works. The biggest competition we have is not our competitors selling great systems. It's people saying ultrasonics doesn't work because they've either bought a poor system or they've installed a system incorrectly or in the wrong places. So mindful of the clock, just in case there are only a couple of questions, just the conclusion. This is an industry proven solution. A lot of people think it's a new technology. It really isn't. It's just one that the industry has been slow to adopt because it's been cheaper to put on biocidal paints, frankly, and to use copper anodes. It will reduce your maintenance cost. We see a lot on recreational vehicles. They didn't used to get to 5 years with their coating. You put this on, you're going to get to 5 years because you're not scrubbing it as often, well, hardly at all. And so you really do, over the course of time, reduce your maintenance cost. You are going to reduce your CO2e, which I know is getting more and more important to people that own a vessel. They really do not want to be damaging the environment. This is not just for hulls. It's for your propulsion, it's for your niche areas, it's for your cooling. So there is no excuse now to have invasive species and nasty things. This is pretty much fit and forget. I know I said once a year go and check. That's a nice to, not a need to do, but we just think it's a good idea if you're serious about keeping your vessel clean. We can retrofit. Yes, we go on new builds, but the majority of what we do is retrofit. Everything's on the dry side. You don't need to be out of the water to do it. It's really quite simple. We literally just epoxy on our equipment. On some metal pipes, it's a weld, but usually there's no hot works or anything like that. It's very simple, very safe, very quick. It is future-proof. Ultrasonics does not have a negative environmental legacy, so it is not going to be subject to the sort of things we're seeing with coatings and we're seeing with anodes, and some of the issues we have with in-water cleaning at different facilities. Biocides are not the long-term solution. There is a whole review going to go on in 2026. Quite what comes out of that, I don't know, but I know the coatings companies are working really hard to remove what biocides they can, but they're working against, frankly, the Germans, the Swedes, the New Zealanders, the Californians, who are all pushing at a far faster pace. Again, we've got zero poisonous environmental legacy, and again, to this proven solution, 5,000 vessel years of operation. That's just for our system, and obviously there are other systems out there. I think that just about leaves me with 5 minutes left for questions. I think I've done quite well there.
Well, Darren, it's Mike. Fantastic. Yeah, thank you very much. Really interesting topic. I've certainly learned a lot. There are some questions. Let me just come to the ones I've got online here. Query from Alexander. I don't know if you can see these on chat. Can you go through the assessment process of installing the system on board a GRP yacht in a bit more detail, both in terms of the drawings required and the actual inspection?
Yeah, so drawings required for GRP, we don't usually need that many, they're usually available. Depending on the size of the vessel. A smaller vessel, we actually wouldn't even need a drawing. If we could cover it with a GEO, we just go on either side of the hull. Again, that's if we're talking hull, not propulsion, not other niche areas, cooling, whatever. We wouldn't need. If it's a larger vessel, yeah, we basically just need a schematic of the area we're protecting, be that a hull, be that a sea chest, be that a box cooler, or if it's a propeller, so we can work out. And we've got a team of naval architects here, and we just knock a drawing up that says, here's where your equipment goes. On a GRP, we would, I don't know if you can see that ring. That ring there would be epoxied onto the dry side on the inside of the hull. A small plate then goes in on it. On GRP, we haven't got to worry about galvanic. Small plate goes in, which when we then screw the transducer into the ring, that plate will form the shape of the hull. So you've got maximum surface to surface contact, which gives you the maximum fidelity of signal. Again, what you'd be looking for if you're doing inspection, Our transducer is the only one that use the ring system. We've got that IP protected, and most glue their transducer face directly to the surface, which is a little bit odd for me, but they do. You just got to make sure that it's strongly on there. And what you can do, if you go on your phone, there are all sorts of apps, I mean, literally hundreds of them, that are sonic tools, and most of them are called sonic tools. And if you get them on your phone and it's nice and quiet, and you hold that against a hull, you will see the signal coming through the hull. You will see it on your phone. You'll just see a little pattern. And if you're getting signal, you can then just kind of move it away and see how far is that signal going. So it's actually quite easy. You can usually tell a poor installation because it looks poor. There'll be epoxy everywhere. It will look a mess. And again, look at what sort of equipment's been fitted. I think we all know it's like anything when you go on a vessel. You can tell if a good job's been done or a dodgy job. And if it's a dodgy job, yeah, get your phone out, see if you can see signal, have a look at the growth around it, see if you can see a pattern of where the signal's dying off. You can sometimes see that when the boat comes out. But the key one to me, GRP, not such a problem. But if you're on pipe work, just make sure that you haven't got dissimilar metals. Just incidentally, the one thing that we do that is an issue, not an issue, but does need to be understood. If you have a cored hull, right, it's got a foam, it's a sandwich construction. In those cases, and only in those cases, the hull does need to be cored out so that we go onto the inside of the outer skin. For quite obvious reasons, that is the only time we insist on a vessel not being in the water. Because yeah, you don't want to be drilling holes in hulls while they're in the water. That's a little bit too high risk. So that is the only time that we would need a vessel to be out of the water.
Thank you, Darren. I've got two questions the same here. What is the approximate cost of fitting your system on a 40-foot yacht? That's been asked by John and Simon, and Ollie was also typing the same question as well. Can you give an answer, please?
40 foot. It's going to be 10. Right. If all we were protecting was the hull, you're talking about, including install, about 6,000 GBP.
Okay, thank you. Simon also says, what is the best coating externally for a Sonihull system on an FRP hull, epoxy or gel coat?
We prefer hard coatings, and we prefer them for two reasons. So we're fairly coatings agnostic. 4 of the biggest coatings companies send us test plates because we've got the only laboratory in the world that can test their plates with the ultrasonics. So we work with them. So we're fairly agnostic. But what we do prefer is we prefer a harder coating. It's going to last you longer. And ultrasonics works really well with that harder coating. The only coating that I don't particularly like, because we see a slightly reduced signal strength and activity at the surface at a microscopic level, is silicon. The softness seems to sort of cushion the reaction. And personally, I'm not a big fan of silicon anyway, because it gets damaged so easily. I've never seen anybody get to a 5-year docking cycle with silicon. There's some big issues around silicon leaching oils, silica oils into the water, which is certainly under the spotlight at the moment. So yeah, I'd go to the hardest coating you can get. It's going to last you a long time, and it'll look great.
And can the system be used on wooden hulls? Tim Rowe wants to know.
No, it can't. It gives out very poor signal on wooden. It's the only thing we kind of steer clear of. And also, so technically, I'd say yes, but because of how wooden is constructed, we could have every drawing under the sun, and then when we get there and you put it on, you find that the wood's got different density here and you get patches. So no, that is the one area I will steer clear of.
And Ollie wants to know, how long is your manufacturer's guarantee? Is there a lifespan on any of the elements of the system?
So our warranty is 2 years, just because it's electronic. Realistically, our old, in a terrible business model, we keep being told, our oldest system is still working from 15 years ago. Which is a terrible business system, but it is quite important. Actually, it's a great point, because it does last a long time. What I would say is, certainly after 10 years, I would perhaps just change out the transducers. If you left your stereo on at home for 10 years, the quality of the sound coming out of the speaker is bound to at some point deteriorate. So I'd do that, and they're not expensive anyway. But it is really important that people understand biofouling has always been considered a running cost. This is a capital expenditure that will last with your vessel. When you sell your vessel on, you can either leave it on and it adds value, or you can take it off and put it on your next vessel. So it is a capital asset. It's not like coatings. It's not like regular cleaning and haul outs. It's this capital asset. And so, yeah, so there is a bit of a mindset shift for vessel operators and owners to come to on that.
Thank you very much.
Power drill has it got?
Say again.
Power drill?
Power drill.
A tower drill. I think it's 3.6 watts. I'm not a technical person for that, but apparently it's. I say it was designed originally to run off batteries on a. So it does that. The recreational one has DC AC. So it's AC 110 and 240. And it also has a DC input, because we get lots of recreational people will run it off batteries for a few weeks at a time, and some even just put a very small solar panel with it. But yeah, the draw is ridiculously negligible, because it was designed for a sailing vessel 15 years ago.
Any other questions?
Have any experiments been done in relation to MIC and steel hulls?
Sorry, I couldn't quite pick that up.
Have any investigations been done into MIC and steel hulls?
In other words,
We're on hundreds of steel hulls, including people like the Dutch Navy, including Maersk. In terms of actual research for that, all we've done is research, can we get a signal through? We've been on steel hulls for multiple years, but no, we haven't done a scientific study of that. It's certainly not an independent one.
Thank you, Darren. Thank you. Appreciate your time, and I thank you for giving up your time, seeing as you're tired and jet lagged or whatever. Much appreciated, and good to hear from you. We've got a copy of your presentation which we'll share with everybody afterwards. And
if anybody does want to get hold of me afterwards, feel free to send me emails or whatever. I'm sure Mike, your team can pass my details on.
Absolutely superb. Thank you
Thank you for your time.
Over and out.
Thanks. Bye.
Right. So we